All right, now let me show you how to create a grid in code. So first we create a grid object. Here we can set row spacing and column spacing. Pretty simple. Now to add elements to this grid, similar to the stack layout, we use the children property. So grid.children.add. The first argument here is view. View is the base class for all visual elements, like labels, images, and so on. So here I can add a label, set the text. The second argument to the add method is called left, and that represents how far from the left of the grid this element should be. In other words, that means what column. So I'm going to put it in the first column. And finally, the third argument is called top, which means how far from the top of the grid or what row should this element be inside. I'm going to put it in the first row. So this is how you add one or more elements inside a grid. Now, if you want to set the row span or column span for an element, you need to use one of the static methods of the grid class. So grid.setRowSpan. Let's say I want this label to take 2 rows. So first of all, I'm going to extract this into a separate variable. Now I add it to the children property. And finally, I pass it here to setRowSpan method. Let's say I want it to take 2 rows. We have another static method on the grid class called setColumnSpan. Again, we pass our element here and specify the number of columns we want this element to take. Interestingly, we have a couple more methods on the grid class. Grid.setRow. So we can pass a label here and put it in the first row. Or grid.setColumn. We pass the element and specify the column. Now, most of the time, we don't use these two methods here, because often we specify them while adding that element in the children collection. Internally, that add method will call these static methods on the grid class. So in the XAML, we use grid.row or grid.column properties to specify the row or column for an element. And I told you that we refer to these properties as attached bindable properties, because these properties do not belong to elements like our label here. They are attached to our label. So when XAML parser parses this XAML file, it will actually call one or more of these static methods on the grid class. And finally, if you want to work with row or column definitions, that's pretty easy. So grid.rowDefinitions.add. We pass a row definition object, new row definition. Let's say we want our first row to have an absolute height of 100 units. So we set height to a new grid length object. In the constructor, first we specify a value, 100. And second, we use grid unit type enumeration to determine if this is an absolute or proportional value. So grid unit type dot absolute. I'm going to copy this. Now, similar to the last example, I want the second row to be twice as tall as the third row. So here I set 2. And to make it proportional, I use star. And similarly, we set this to 1 and star. This enumeration also has another member, auto, which basically means the height of this row should be calculated based on its children. So once again, you can see that defining user interfaces in XAML is a lot simpler and cleaner than in code behind. Here we have a bit of distraction. We have to create objects, we have to write more code, but I'm not saying this is bad. there are times that we need to use code behind to generate user interfaces. For example, imagine you want to render a calendar. You cannot hard code the days and months of a calendar using XAML. It's going to be tedious. In those cases, it's better to use code behind and use a couple of loops to dynamically generate elements and put them in a grid. Or if you want to generate a photo gallery, again, we don't know how many photos we're going to put in the gallery, so we cannot hard code them in XAML. In that case, it's better to use code behind for that. So ideally, you should be able to work with both XAML and code behind, but in this course, most of our focus will be on XAML. All right, enough theory. Now it's time for an exercise.